While the more extensive discussion of roots, from square roots through other kinds of roots, will come in other videos, what we have is a way of coming back to our rules for exponents and adding in some new ones that allow us to deal with roots instead as exponents. And that first rule that connects those together and can bring us back into our rules for exponents is that any root can be written with a power that would be 1 over a number. So depending on what root we have, that would control the denominator that we see in this particular power. If we had a square root, then we would have a power of 1 over 2. So square root, second root, denominator is 2. Cube root, aka third root, the denominator would be 3. 17th root, the denominator would be 17. So this gives us a connection and allows us to try to come back, and in some cases, very nicely and quickly simplify expressions simply using our rules for exponents by throwing this one in the mix, and then we'll incorporate another one as well to handle other kinds of powers than just fractions that have a 1 on top. But for right now, very quickly, just to emphasize that connection as well as show you that things can be calculated and handled in maybe a quicker and more efficient fashion sometimes. For instance here, 27 to a power of 1/3. Just to make the connection back to roots, what that means is because our power has a denominator of 3, we're going to have a cube root. Now officially speaking, with our calculators, what we can do is we can type in directly a 27 and tell it to raise that to a power of 1/3 and automatically have that calculate our answer of 3 in case we don't automatically know the cube root of 27 right off the top of our heads. And that would be even more so the case here. Not many of us would remember fifth roots, but when we've got that power of 1/5, a fifth root is exactly what we're building. So our fifth root here of -32. Now, while we might be able to type something like a fifth root into our calculators, we definitely can type in a power of 1/5. So this gives us a nice way of more directly with our calculator trying to bang out a simplified version of that kind of expression. To give us a -2. Now for something that's got a variable in it where we can try to bring in those other rules for exponents that we have, very quick comment here, because that power that we see outside the parentheses has a denominator of 2, that means that we are coming back again to the square root, the ever popular square root. And so officially speaking, as a root, this would be the square root of x to the power of 4. But to more quickly work out a simplified version of that answer, what we can do is we can use our rule for exponents that says when we have a power on the inside of the parentheses and power on the outside of the parentheses, we can multiply those together. Power of 4 times the power of 1/2 gives us power of 2. So as far as a final answer that we can generate very quickly using those rules for exponents, we have x squared. Well, this only takes care of so much. We have plenty of other kinds of things that could happen. For instance, what about 9 to the power of 3 over 2? That doesn't have a power with a 1 on the top. That has a power with a 3 on the top. And so how could we address that? Well, again, calling back to our rules for exponents, we have the option of breaking apart a fraction as a multiplication problem. And so this can lead us to two other rules that are a little bit more generic. We can break that power up so that the 3 on the top is dealt with first, and the fraction 1 over, in this case 1 over 2, would be dealt with second. And notice what happens here is that we would get a much larger number showing up before we address that power of 1/2, aka the square root. And we get our answer. Alternately, if we address the fraction part of it first, so still splitting this up as a 3 times a 1/2, but using the 1/2 power before the power of 3. Then the square root that we have to deal with is much more familiar to us, and we get something that, again, still yields that same answer. So, yes, we have options. Sometimes one of those options is more preferable to the other. When we're talking about simplifying numerical problems that have these fraction powers, it might be more worthwhile to us to take care of the fraction part, aka the root, first, before dealing with the rest. But essentially, this affords us now the opportunity to mention 2 more general rules for dealing with fraction powers. If we have a fraction power, we can understand that as the bottom, the denominator of our power, refers to the root, and the numerator refers to a normal power that can either be inside of our root or outside of our root, depending on our purposes and depending on our perspectives. How would we best like to try to work things out? Would we like to keep the power underneath the root, or would we rather keep it outside the root, deal with the root first? So we have those kinds of choices available to us. So to emphasize some examples here, one that works out already and one that we'll do together in just a moment. 8 with a power of 4 over 3. We again have those 2 options of taking care of the 4 either inside of the root or outside of the root. So if we use the first version of our rule and have that cube root, the third root, based on the denominator, appearing where the 4 part of our power is underneath. That means that 8 to the power of 4 would be handled first, and then the cube root would be calculated. Or what I consider a little bit more direct and a little less challenging to work through, especially without the use of a calculator, dealing with the root first and saving the power of 4 for second. The cube root of 8, something that we might be much more familiar with, and say, oh, okay, well that's a 2, and then a power of 4, 2 to a power of 4 give us that same answer of 16. So I would argue that that option works more nicely for us when we have numbers. So in this particular case, my suggestion would be to follow that lead, and let's deal with the root business first. So we would say, let's look at taking a cube root of the number negative 64 over 27, and after addressing that cube root, we will take care of the power from the top, which is a 2. This gives us more of a chance to handle the root with some possibly friendlier numbers. Again, with or without the use of a calculator is your own personal preference. Dealing with that cube root, one of the other rules that we had for powers said, hey, what we can do is we can take that cube root and we can apply it to the top and to the bottom separately. So we can take the cube root of the negative 64, and we can take the cube root of 27. We'll work those out, and then afterwards, again, we have to worry about that power of 2. So based on what we know, or based on what we can do with our calculator, cube root of negative 64 would be a negative 4. Cube root of 27, we actually had that pop up earlier, would be a 3. And so now we take that fraction answer -4/3, we still have to worry about that power of 2 outside of our parentheses. So we're going to take that number and square it to come up with our final answer. Now this is, you might say, the long way around. Didn't I mention a few minutes ago that we could more directly type something like this into the calculator? Well, you betcha. So rather than having to work out those steps by hand, because we have only numbers appearing here and we would like to calculate a final answer, what we can try to do instead, just to make sure that we're avoiding any sort of issues that might arise from calculator usage, we still would want to handle things separately. So we still use the idea of separating things out into a calculation for the numerator, -64 to the power of 2/3. With my calculator, bang that out, and have my calculator generate the answer 16 for that numerator. And then likewise, get that 27 to the power of 2/3 and have the calculator bang that out to give me the 9. So we could do that as well, and yes, I admit that would be much faster. So, we have all of our rules for, or properties for exponents, for powers, and to that list, we are now adding what can we do with fraction powers where we have 1 over a number or any number over any other number, how that connects back in with, well, our new topic now being roots. So the roots showing up here, all the other ones now with 2 extras in the mix, give us the opportunity to do all those same kinds of simplification problems that we saw previously, like these next examples. But now we have more variety that we can incorporate because now we can use fraction powers, like what we see in these different examples here, and how those fraction powers end up working out. Last few of these obviously already worked out, but just to hit a few more together, if we are emphasizing the connection with roots, then this next example has the parentheses -32 parentheses power of 7 over 5. And we could choose to do the root part first. The denominator tells us which root we would have. And then again, if we're working things out by hand, my argument is that it's nicer for us to do the root first and save the numerator part of that power for the last part that we have to calculate. So taking the 5th root of -32, we would have a -2 coming out of that. And we would still have to raise that to the power of 7. So then, raising that to a power of 7, we would still get a negative answer there. And that would be a -128. We could again just type that directly into the calculator. Parentheses -32, parentheses, type in the power. We would need to put that in parentheses as well, more than likely with the calculators that we have that we would be using in this case. We would hit our power button, and then we would put in parentheses 7/5. That way we make sure to tell the calculator the correct thing for it to work out. When we don't have the numbers, we resort back to those properties of exponents, those rules for exponents that we've had. And so like an earlier example, we say, hey, what we can do is, in order to simplify, use our rule that says that in this particular case, we would take the power from the inside times the power from the outside, and that would give us, for our final answer, x with a power of 8. With our other rules, for the next example, when we multiply things, we say we can add the powers together. So, if we go about adding those powers together, then we would need a common denominator. Common denominator would be 21. We would need to adjust the fraction 1/3 and adjust the fraction 1/7. So that would mean that we would have a 7/21 plus a 3/21. Now we're equipped to actually add those powers together and get x with a power of 10/21. 10/21 can't be simplified, so by itself, this could be considered a perfectly acceptable answer. But to again emphasize the connection to roots, the denominator of our power is telling us what kind of root we have, and so we could, at first, interpret this as the 21st root, and we could keep the power underneath the root symbol, or as we said before, we can also do the root and keep the numerator part of that power for outside. So we have those two options. Similarly, for the other two examples here that are already worked out, just to show you a little bit more of that variety where we've got those different kinds of fraction powers appearing. Another situation where we've got the adding powers rule that is used. What we come out with is a negative power, so just a little refresher there. The negative power says that we would kick things down to the denominator here. This is a regular x, so the negative power says let's boot that x down to the denominator. If we keep the power there, or if we rewrite that using roots, not just negative powers, but also having a division set up here originally means that we would want to take the power from the top, -1/5, minus the power from the bottom, so minus a -3/10, and simplifying that, and again having the option of either using a fraction power for our answer or rewriting that using a root. So we have that kind of flexibility, and we can now fold that in to our other discussions that more directly address the roots, the different kinds of roots that we have, focusing first on square roots and then moving on to other kinds of roots.